So we started off our research about 15, 16 years ago in the University of Manchester, and we were really interested in the fundamental physics in behind how molecules self-assemble and come together, what drives their self-assembly in terms of the electrostatic interactions, van der Waals interactions and hydrogen bonding. Being inspired by nature helps us create materials that are not only functional, they're structurally reproducible, so that really helps reduce batch-to-batch variability of any materials that we produce, and that allows researchers to then use them to make products in a confident way to be translated into the clinic. We decided to take the next big step, that really exciting step, to actually commercialise our materials when we realised that they had potential to really make a difference to people's lives. That is, being able to translate our materials, develop them for a range of different cell types to be translated and used by medics, researchers, to make that big step, to make a difference to people's lives. So Manchester BIOGEL has a family of peptogel products. That's important because every cell needs a different microenvironment to really thrive and grow. That can be different functionality, it can be different mechanical properties. We have a tunable family of peptide materials that people can buy and try, and then use them to commercialize their product for their end application. So really excitingly, our materials have already been tried in mice, in rats, in sheep and in pigs, and they are non-immunogenic and there's no toxicity effects. We've also done tests to check that there's no accumulation of our material in the body, and there isn't. Everything is degraded and passed out through the urine. There's no accumulation in the body. The structure of our materials mimics that of extracellular matrix in our body. So many researchers are using our materials as scaffolds for two-dimensional and three-dimensional tissue engineering. That can be for culturing many different cell types and using them then to translate into the clinic. So our hydrogels can also be incorporated into medical devices as an additional component, and they're good in those components to deliver cells, for example, or therapeutics, or antibiotics even. I'm so excited that we are developing commercial materials that are actually going to be used for real applications to help people and improve people's quality of life. To think back 16 years ago when we made that first peptide in our lab in Manchester University to where we are now, it's really a remarkable transition and an exciting time for the company.